Welcome to the Aviation Safety Community Podcast, presented by the aviation safety community and by today's sponsor, FlightLogix, dedicated to progressing aviation safety, leadership, training and research in the air and on the ground. In today's episode, our host, Grenville Hudson, interviews Dr. Matt Everson, the Aviation Postgraduate Course Director at Swinburne University, regarding the future of technology and data in the aviation industry.
Welcome to the Aviation Safety Community Podcast Service, and today we're sponsored by FlightLogix, and our guest is Dr. Matt Everson from the Aviation Department of Swinburne University in Melbourne. How are you going, Matt?
I'm good. Morning, Grenville.
That's good. Matt, you've got a pretty extensive background in aviation safety and in particular technology in the cockpit. Just wondering if you could maybe give us a bit of a insight of what you've been doing to date.
To date, yeah, it's been suddenly realise how old you are when you go back over and try and think about all these things. So I started my actually industry career back in an airline in the UK, working as a flight data analyst. So I was looking at all the flight data records and running the flight data management program for them. Prior to that, I'd actually been studying at Grenville University on their human factors and safety management program, and I did my PhD with them in collaboration with the UK Civil Aviation Authority, looking at the effects of technology on pilot skills, looking at the degradation of manual flying skills. And then after my time in the airlines, I actually went back to Cranfield to work as a lecturer and a researcher on the same sort of issues, really. So in various airlines and air traffic control centres around the world, looking at how automation changes human skills and is changing the workplace environment. And I came to Australia in 2012, so I now consider myself an Aussie. And since 2013, I've been working at Swinburne University in the aviation department as a human factors specialist. And again, engaged with projects with CASA and various airlines, mostly looking at how we measure pilot performance now, but future ways of measuring pilot performance. Things like looking at eye tracking technology, and branching out to our other departments to think how they might help us. So we're thinking about our data science department and how they might apply their skills to the aviation industry to help us improve in the future. And yeah, it didn't get more broader than that nowadays. So looking at training and things like that.
So the flight data analysis side of things is quite an interesting area because we're going to be moving more into that with the new regulations coming into Australia. Part 121 will require operators to have that for aircraft above a certain weight. So any tips that you might be able to give to people who are setting this sort of thing up?
Yeah, tips. Well, it's interesting. It's interesting that we kind of view it as a new thing, but it's not a new thing. We've been doing it since the 1960s, since the Trident first came in. But I think running a good flight data management program and integrating that to your safety management system is a challenge and is key, especially in a smaller operator. My tips, I guess, would be don't get overwhelmed by data volume. So it's been 15 years since I started doing this, and when I first started with our Boeing fleet, we had maybe 5, 6, 10 parameters coming off the aeroplane, whereas nowadays, pretty much every aeroplane you have, even our fleet of Cessnas that we operate for flight training, can download hundreds, if not thousands of parameters every eighth of a second, so you'll be overwhelmed by data. I guess it's actually not to get stuck in the technical side of things and just have a very clear idea of what you want to measure. What is it you're trying to look for, and how are you going to measure it, and how are you going to implement those measures in your flight data monitoring program, and then scale it up from there.
Is it something that you need an outsourced resource for it? Like, do you need a professional person to do this? Or can
yes
you do
and
it
no.
yourself?
It depends on the scale of the company, really. I mean, there's a lot you can do yourself these days. You can outsource to the sort of the initial analysis part of the software to turn some of the raw data into information. And then there's the kind of the higher level analysis of what do you do with that information, how does it relate to your safety management system and your operation. There are, if you like, turnkey solutions that you can just send all of your data to, and they will come back with a sort of a very high-level overview of your safety performance and do the basic monitoring. I don't think there's anything wrong with those services. I think they do a really good job. It gives you access to a lot of very sophisticated data processing and, in a lot of cases, the ability to compare your data with other operators' data in a sort of anonymized way. So that's a very good thing. But I would, if you can, I guess I'd say to some extent, be visible of your own data and be involved with it, even if that means bringing in some expertise or developing it, because taking ownership of your own data and understanding what it's showing you it's the processing which is important, and it's the understanding of what it's showing you which is important, not just the taking the results, if you like.
So I know that quick access recorders are used, and there's a lot of change in that technology. Is that right, or is it pretty easy to use or download from now?
Yeah, and I don't want to sound like I'm an expert in this field anymore because, like I say, technology moves so quickly, and I've been out of the field directly working with flight data recorders and QARs for a decade now. But just from the involvement I've had with our fleet of Garmin-equipped aeroplanes, just taking the SD card out of a G1000, there's all sorts of data that's available to you. You can get wireless integration now, so the data can be automatically downloaded off the aeroplane very reliably and very quickly, and there are easy to access applications and pieces of software to transform that into, if you like, information. So not just numbers now, but actual graphical plots of what's going on. So it's a much easier process. It's much easier to access now. And again, it depends on the aeroplane fleet and what you're operating. But the real tricky part, as I said before, is then making some sense of that, because having doing a deep dive into one flight is interesting and often is required if there's been an incident or you have a reason to look down there. But the real value comes in looking not at the exceptional events, but across the normal flights and looking at flights en masse and having some basic sort of statistical analysis skills to condense that data down into some sort of performance metric which you want to apply and can actually monitor in your safety management system, and then look across a whole range of flights, in fact, at best all of the flights you perform, and start to take an understanding of that's probably the more challenging part these days, I think.
So it's the mundane information that you really want, as they say.
Yeah, it is. It's mundane, but also subtle. Yeah. So when we have great exceedances, they're much easier to see in the data. And obviously you'll have often crews reporting back to them, and it ties in with your safety reporting culture. But when you're trying to look at trends and early indications of are you operating on the inner of the envelope or towards the edge of the envelope, that's a much more subtle thing, and what that variance looks like. So actually a good grasp of statistics and some basic sort of quality management skills, quantitative quality management skills can be really useful there.
Yeah. And you mentioned the eye tracking technology, which is really interesting, because I think with all these new fatigue risk management systems that people want to put in place, that's a technology that you could certainly use in the cockpit. Where's that got to now?
It's maturing very well. I mean, there's a whole. It's a collection of technologies, really. I mean, there are the physical technology, which is a camera which looks at the eye and can determine whether crew are looking, is something. But then the way you process that information can tell you a lot of different things. So there are applications which look at blink rate, and applications which look at the kind of the saccades, how the eye is scanning around the various instruments. There's been a lot of attention in terms of fatigue and trying to use them to build fatigue metrics. In the laboratory, it's getting much more sophisticated. I think the jump at the moment is to operationalize that. What can we do in terms of actually making that commonplace in the cockpit, and how can we use that information? And we're a long way from doing that at the moment. So, I mean, there are trials going on with there have been trials going on with various airlines and various operators to integrate the physical equipment into the cockpit and get that working, and that's successful. But it comes back to the same challenges. You're suddenly going to be drowning in data, and what does it mean? And you've got to be really careful with these things as well, not to follow false leads on what they're telling you, because we don't really know how to interpret that data at the moment. And I'm taking that more from a sort of a general pilot performance measurement view, which is where I'm interested. The fatigue side of things is probably clearer, and I'd imagine there are various applications looking at real-time fatigue monitoring and whether we've got crew which are falling asleep or micro-sleeping, and that's like, again, at the very coarse end where we've got real problems. on the flight deck that we need to do about there and then, but going back to those subtle measures of how do we look at, across a route and which of our routes are causing slight reductions in alertness and things like that. That's going to take longer to implement and really get to understand.
I believe they use this technology in the trucking industry, and I'm not too sure what sort of results they've had. But
I have to say I'm not entirely across the trucking industry's literature either, but I know they've started to implement it as well. And you look to and cars as well. I mean, because the technology cycle in the automotive industry is much more rapid. And there's more consumer technology, right? So it ends up in cars and bikes and trucks a little bit more rapidly. And it's effective, and I think it's being effective. And again, it is still a problem of how do we use that data. It's all right saying that you might develop a queue to say someone is their alertness is at a particularly low state, but then what do you do with that information for the best? Do you set up a giant great warning horn in the cockpit? I mean, probably not. No, that's probably not the best way of dealing with it. And in the long term, if we want to start comparing individuals and looking at particular parts of the operation, we need to be able to interpret that information. So a lot of work to do there.
Yeah. And in terms of technology, just in general, like the introduction of new technologies on the flight deck, what are some of the challenges that we're facing from a safety point of view there?
Lots. The one that comes straight to mind, and this is because of a PhD student of mine who's working on this, is regulation, because we're a very conservative industry, and as we should be to a certain extent. We've got a safety record to preserve, and we achieve that through good, strong, adequate regulation. But the pace of technology change at the moment is really quite exhausting in a way. There's so much stuff coming along. VR technology for training, all this sort of new pilot performance monitoring and sensing equipment that we've got drives towards single pilot flight deck. And all of this is going to have to be assessed for safety. And I think the current system that we've got for implementing or taking that technology from the testbed to the operational environment, the regulatory processes we have aren't going to cope with it very well. And there is a lot of pressure from people. I guess you see it more in the automotive world to adopt these technologies before we really understand how to do so safely. Yeah. So I think the regulators are going to have to come along and seriously think about the ways that they can change the process. I mean, we've had, from a human factors point of view, back in 2013, the implementation of new regulations to the integrated human factors consideration to flight deck designs, which was a real push ahead in the general way we do it. It's like more of a performance-based approach to new technologies. So rather than a holistic approach, so rather than certifying a new piece of flight deck technology on a checklist of criteria, it would be a case of collecting data, seeing that technology in operation with the rest of the systems and the human in the loop, and understanding the effects and then certifying it off the back of that evidence. Yeah. Well, all of that requires an awful lot of work and an awful lot of data and an awful lot of interpretation. Absolutely. And if we're going to be doing that a lot, that's going to be challenging.
Yeah, and you talked about single pilot operations, and the move towards that. Where do you see that going at the moment?
It's kind of exciting for me. It's an interesting conversation to have with certainly our students, because I think they perceive it as a threat to a certain extent, and I can understand why. I'm of the opinion that it's inevitable. We've seen this in the past. We've moved from 5 crew cockpits to 4 to 3 to 2 so I think the next logical step is to, unmanned, unpersoned flight, but I think for reasons of social reasons we won't see that. So reducing to a single pilot on the flight deck seems a logical move to me, and there's a lot of research going on. There's a lot of momentum behind that research, but it's going to really change the way I think some of the more softer professional skills, I don't like the word soft, but like communications and how do we liaise with or integrate very closely with crew members that are now on the ground and share technical information between the ground and the air. And there are going to be, in order to make that happen, we're going to have new tools, and some of those tools are going to be very sophisticated types of automation where we've got AI, artificial intelligence, supporting pilots. Yeah. So not just the traditional types of automation which we have at the moment, which are sort of fairly deterministic, and by that I mean push that button, it does one thing, and there's a constrained amount of logic as to what it does,
Yes.
to these sudden very complicated AI systems where they're supporting you in decisions, but you can't necessarily tell how they're coming to that conclusion. It is like another human on the flight deck. How do we... they're going to be vital to be able to reduce the workload on the flight deck to a level where a single person can cope adequately and safely. But how do we then certify those sorts of technologies? We're seeing these challenges all around, and I have the privilege of working across a lot of different industries, not just aviation, and it's a challenge everywhere. But I think we're one of the high risk cases of application where we're really going to have to solve that problem because we can't get it wrong.
Yeah. I think passengers still want to know that there's someone up the front with some skin in the game.
Right. And honestly, that's a very deep-rooted psychological thing, and so do I. I don't particularly like travelling on automated transport systems like trains.
Yeah. It'd be interesting with the new sort of personal mobility type scenarios to see how that all sort of fits together in the...
Yeah, absolutely. So you're talking about Uber air taxis and things like that, so unmanned drones. It's interesting that the initial approach to that is that the broad regulatory system stipulates that there will have to be a human supervisor in the vehicle. And then that's pretty much where it stops at the moment. It's like what role that human supervisor is actually going to have, or what level of authority or control they will have over the system. We don't quite know yet. And there is a danger that we do what we did in the 70s and 80s, where we look as the human as a sort of a thing, an uncomfortable problem that we need to remove, but we just have to keep them there temporarily until we can figure out how to get them out of the system. And what we do is we build a flight deck which, and to the... without being detrimental to Airbus or Boeing or Embraer, current generations of flight decks are not perfect by any means. They're a compromise, and we didn't go at it with the right philosophy. We tried to automate as much as we can without really taking a very human-centric view. And if you ask pilots nowadays, I'm sure they'd share a lot of frustrations with modern-day automation. It's got a lot better, but there are still a lot of problems with it, and we've got to avoid doing that again this time. So if there is a failure that the human supervisor needs to intervene with, have they actually got the means to do that? Can they spot the failure? Can they do something useful? Yeah. Are we using the human strength? And we've really got to ask ourselves, what do we want the human there for? Because I'm pretty sure that they've got some really good strengths. I hope, otherwise I'm out of a job.
Yeah, what about, you mentioned virtual reality, and I guess that's more in the training sort of field, but where's that sit now? Is it becoming more accessible?
Yeah, it's certainly accessible. Gaming technology has pushed it. The consumer market has pushed it forwards immeasurably. It's funny. It depends. From month to month, you have conversations with people, and there's a new trend and things we're really interested in. But VR technology is one of the ones that seems to be persistent. And yeah, there's a lot of experimentation with what it can do. And I think the challenge at the moment is really understanding what it can do for us and what it is best to do for us. It's very compelling. It's very interesting. We're riding that little wave at the moment that it might be able to improve training scenarios just because people are more engaged by using it because it's interesting. But at some stage, we then start having to ask ourselves, well, what are we actually introducing? What benefits does it actually have for us? And is it just a novelty? I'm pretty sure in the long run, it's not just a novelty. And again, part of what my PhD student is looking into is, how do we quantify that and where should we use it?
I've heard of it being used in ground training, like as in ground support equipment, moving ground support equipment or controlling ground support equipment. Is that the case? Is it?
Yeah, I've seen a few applications of that too, training pushback drivers, and I've seen it used in training general ramp staff working around aeroplanes and sort of familiarising them with the environment. And I think if you get a grip of that, the immersion part of it, so you feel like you're there and you can start to get a slightly more immersive sense of the environment, I think it's useful for that, if that's a cue that you need. In flight training, which I guess is the area where I'm sort of most interested, I don't think it's entirely clear what the use case is yet. Yeah. I'm sure there will be one. The fact that it's portable and relatively low cost, I think is going to change the training world. We might be able to make training more bespoke and give training scenarios for people to take home rather than bring them into centralized simulation centers.
Yeah.
But then we've been able to do that with desktop computer training for a long time as well, and we haven't really got around that at the moment. So still, I think, not to preach, but my word of caution at this point would be get a really clear idea of what you're trying to do with the technology and why before you pick it up. But I'm all for experimentation. I think any general experimentation in this area is good.
So look, thank you very much for coming along and having a chat with us. I was just wondering, have you got a feel of what you think is the big challenge safety-wise that's facing the industry at the moment? Is there any one particular thing that you could, or maybe a couple, that you think we need to say?
It's like, pick your favourite. There are a few. I think what we've been talking about before is this. Well, for me, looking ahead into the far ahead into the future, because as an academic, that's what excites me. And I think the introduction of single pilot cockpit operations is the big thing for me. That's the realistic thing that's going to come into operations, which I think we really need to be able to deal with. But we've talked about that. So I guess maybe pilot. But I think really, I guess because I'm a human factors person, I tend to look more towards the human, and my concern would be over how we look after our crew in the new operating environment. And the challenges of sensing technology, being better able to take information from the crew and understand how they're performing, and how do we do that and use it in a way that's acceptable to them, but also beneficial to them. So I'm not sure I see it as a threat. I see it as an opportunity. I think I see more opportunities. So my frustration with the flight data monitoring world was always that its analysis was too crude and too shallow, that we seem to satisfy ourselves just by collecting data and using it. But I think nowadays I see on the horizon all sorts of really cool ways of interpreting data, and I would like to say I think the potential that's out there now is to use it to be able to support individual pilots, to look at their needs and to make bespoke training scenarios for them to actually enhance the way we train them. I think that's the way we're going to improve safety, is to make better training scenarios and better learning experiences. So I think we're on the cusp with a lot of the information technology developments of being able to do that. It's my, if you like, the threat, I suppose, is the willingness and the ability of operators to be able to go with that and implement things, because it is going to take effort and it will take investment. And it's new and it's probably a bit scary because it looks different. But I think providing support to operators to be able to do that is going to be vital.
Cool. Well, look, Matt, thanks so much for coming along today. It's very much appreciated, and we will talk to you again soon, I hope.
Yeah, always good to chat. Thanks,
okay. Cheers.
We would like to thank our sponsor for this episode, FlightLogix, for their continued support throughout this podcast's production. FlightLogix, providing low-cost aviation safety department solutions.
Thanks for listening to this episode. Be sure to like and subscribe if you liked our content, and if you're interested in learning more, feel free to find us at aviationsafetycommunity.com.au, or if you wish to continue watching, have a browse of our YouTube channel to find some more episodes and content.